the purpose of what we're doing here is cubics, graphing cubics, which is just another type of function. We'll have a look at our learning goal. We want to recognize and determine the features of cubic functions, particularly, at least for this video here, this guy here. We're going to look at the shape of it, the intercepts, and the behavior as x goes plus and minus infinity. Right? There are 4 formations of cubic functions. We are only going to be really focusing on this one in this lesson. I just want to zoom up and have a look at just y equals x cubed and why it's got its shape. So we're going to have a look at this. When x is 0, y is 0. That's why it sits on the origin. So when x is 0, y is 0 cubed. 0 cubed is 0. Right. We can have a look at it as it shifts to the right as we go along. When x is 1, so when x is 1, we can see y is going to be 1 cubed, which is equal to 1. So that kind of corresponds to this point here, x being 1, y being 1. And it kind of shifts up pretty rapidly. So if we just looked at x equals 2 cubed, which is 8, and we can see it's like it would be up here, right? It would correspond with 8 up there. Right, and so we can see it would just shoot up as we went towards positive infinity. The graph would just keep shooting up that way. Okay. We can consider the negatives. So when x is equal to -1, this point here, we can see the corresponding y value is going to be -1. And if we substitute it in, -1 cubed, that's equal to -1. -1 times -1 times -1. Okay, 3 negatives multiplied together gives you a negative. And so when it's cubed, a negative number cubed is always going to be negative for that reason. So when you go x equals -2, it takes this symmetrical shape down here, and as you go further negative, the graph will continue down that way. All right, focusing on this formation here. All right, I might draw it over here. When we have got y equals ax minus b cubed plus c, all right, similar to quadratics, this is a vertical shift. And we'll just quickly flick over to Desmos and get a grip of this. All right, so here we can see y equals x minus 0 cubed plus 0. Essentially, we've done nothing to x minus cubed. If we ever play around with this, so we play around here in the vertical shift, okay, you can change it to x minus 1, and it will shift it to the right. And you can kind of think of this because this is just a root of the function which occurs at x equals 1, right? Because 1 minus 1 would be 0, right? And so we can play around with that. We can go plus 3 to shift it over to the left. We can also use some horizontal and vertical shifting here. You can see that this just shifts the graph vertically and horizontally, right? You can kind of think of it just as shifting the point of inflection, right? So if I just go back to 0, 0, if I want to shift the point of inflection to the right, okay, I would go minus 3 to the right, and if I want to go up 2, I just go plus 2. So the point of inflection has gone from 0, 0 to across to the left, across to the right, 3, and up 2. Right, and we can also look at a dilation factor. Right, if we make it 2, the thing just gets steeper. If we make it 3, the thing just gets steeper. If we make it 30, the thing gets really, really steep. Okay, and if we make it negative, it just reflects itself over that point of inflection. Positive, negative, positive, negative there. Right, and you can make it negative steeper. So -5. No, that's +5, goose. -4, -5. We're being asked to sketch this cubic here, and we saw that with a cubic there is vertical and horizontal shift, and that shifts the point of inflection, where the point of inflection, whereas that's the point where it turns around, kind of saddles around, is at BC. All right, so we can just read off, we've got a point of inflection at 2, at -2, -5. So it's been shifted to the left 2 units and down 2 units. Right. What I also need to do is I need to see if there's any x or y intercepts. So now here I'm going to find the y-intercept, and the way I do that is I let x equal 0, so the y equals 0 plus 2 cubed minus 5, so y is equal to 2 cubed minus 5, y is equal to 8 minus 5, so y is equal to 3. Okay, that is my y-intercept. Find x-intercept. I let y equal 0, so 0 equals x plus 2 cubed minus 5, so I've got 5 equals x minus 2 cubed, so the cube root of 5 is equal to, which should be plus x plus 2, so then the cube root of 5 minus 2 is equal to x, which, by the way, is roughly equal to about -1/2, roughly. Okay, because this would be about 1.5. Okay, because the cube root of 8 is 2, and the cube root of 1 is 1. So you're kind of finding middle ground there. Not exactly. Okay, it's just an estimate. Alright, and then here I just need to sketch this. So I've got my y-intercept, I've got my x-intercept, I've got my point of inflection, so that's really all I need. So I draw up my axis here, y-axis, x-axis, and here I've got an x-intercept at -0.5 and a y-intercept at 3, so right up here. And I've also got a point of inflection, x being -2, y being -5, right down there. Okay, and so I'll just put this in. This is my point of inflection here, and my graph does this behavior. I'll draw this, I'll scale this out a little bit larger. So this is what's happening. Here's my point of inflection, and it's positive, so I know it takes this shape here. Now it goes up through here and carries on forever. And it carries on down here forever, because that is the behavior of a cubic function, where I know I've got my point of inflection here, an x-intercept there, and a y-intercept there. So those are my 3 crucial points that I need to be able to plot on a graph.